And so we can do this if from 1 to 1.5 we have an increase of 3/4. From 1.5 to 2 we have an increase of 5/4. From 2 to 2.5 we have an increase of 7/4. And then from 2.5 to 3 we have an increase of 9/4. Now our increases are going up by the same amount each time. 7/4 plus 9/4 gives us our 16/4, our total increase of 4 as we go from 2 to 3. And so that says that a better output for an input of 2.5 is 3 plus an increase of 7/4. So that gives us 4 3/4 as the desired output. And what is happening here is that you are beginning to get the idea of taking this table of values and doing what today is called a quadratic interpolation. So you're no longer using just a straight line to figure out what number should come out. You're using a much more sophisticated kind of technique for interpolation. And this idea of using a quadratic interpolation would be more fully developed by Brahmagupta. And Brahmagupta would actually show how to do an arbitrary quadratic interpolation for any kind of function that you might put in. So if you know the value of first differences and you know the values of the second differences, you can then use those in order to get a better idea of what the intermediate values in your table should be. Brahmagupta is an extremely important mathematician and astronomer. He taught at the great astronomical center of Ujjain, which is located on the western edge of Madhya Pradesh, near modern Rajasthan. Ujjain was founded around the 4th century BC, and it would exist until the 12th century AD. It would be an important mathematical center, and it would be so important as an astronomical center that it would mark 0 longitude, or what was the first meridian for Indian astronomers. Now, the first meridian in our modern world is the line of Greenwich, and that's chosen because of the Royal Astronomical Observatory in Greenwich. It's decided that that is 0 longitude, and you measure the longitudes east and west from Greenwich. In ancient Indian astronomy, that 0 mark of longitude was located going right through the center of Ujjain, the great astronomical center. As I mentioned before, Brahmagupta is the first person known to have used 0. He also is one of the first people known to have used negative numbers. Now, we will see in China that negative numbers came in much earlier, but only as intermediate steps. And Brahmagupta realized that you needed to be able to actually work with negative numbers and accept negative numbers as possible solutions. And so far as we know, he's the first person actually to accept negative numbers as solutions to mathematical problems. This interpolation formula, this quadratic interpolation, is often attributed to Newton, who would then go on and extend this to interpolation by polynomials of higher degree, cubic polynomials, 4th degree polynomials, and so on. Eventually, the Indian astronomers would realize how to do this, how to not just take first differences and second differences, but to work with third differences, fourth differences, as many as you needed in order to get a very accurate interpolation of the values. Brahmagupta also did work on Diophantine equations. So these are equations that were studied by Diophantus. And one of the examples of these that I gave earlier is the problem of Pythagorean triples. So 3, 4, 5, 3 squared plus 4 squared equals 5 squared. The kind of Diophantine equations that Brahmagupta studied, equations where we're only interested in integer solutions, are things like x squared minus 8y squared equals 1. If you find 2 integers that solve this, then the ratio of those integers gives you a very good approximation to the square root of 8, a good rational approximation. And he found a number of solutions to this. We don't know exactly the method that he used. All we know are the answers that he found. But for example, he showed that 3 squared minus 8 times 1 squared is equal to 1. And 17 squared minus 8 times 6 squared is equal to 1. And 3,363 squared minus 8 times 1,189 squared is equal to 1. Another one of the examples of the Diophantine equations that Brahmagupta studied are something squared minus 61 times something else squared is equal to 1. And here the answer gets much more complicated. One of the answers that Brahmagupta actually came up with to this is you take 1,766,319,049, you square it, you subtract 61 times 226,153,980, this quantity gets squared, and then that difference is actually equal to 1. This idea would further be developed by the last of the great Indian astronomers that I want to talk about, Bhaskara Acharya, born in 1114, died in 1185. He also was interested in this problem of finding polynomials that interpolate values in these tables of sines and cosines and versed signs. And he came up with something that would really anticipate developments in Western Europe that would come many, many hundreds of years later. And that is, in order to find a good polynomial to approximate the sine, he considered the rate at which the sine function is changing. What Bhaskara actually was looking at is the derivative of the sine function. And what he realized is that the rate at which the sine function changes is given by the cosine function. And the rate at which the cosine function changes is given by the negative of the sine function. And he saw how to use this fact in order to find what today we would call a Taylor polynomial, a quadratic polynomial that does a very good approximation to the sine function, very close to any value that you happen to know the exact value of the sine function for. So if you know the exact value of the sine, you know the exact value of the cosine, you can work out this quadratic approximation. And this really marks a new episode in the understanding of polynomials, because up until now, polynomials had been thought of simply as things that are useful for solving problems that